On this Ford F150 2.7 EcoBoost, P0101 is a mass airflow performance type code. In plain terms, the engine controller may be seeing an airflow signal that does not line up with what it expects. The truck may hesitate, idle rough, lack power, or just turn the light on with little complaint. Broadly, possible fault areas can include the air intake path, vacuum or hose leaks, sensor wiring or connector issues, and other engine condition problems that affect measured airflow. The important point is that this diagnostic path gives us routing and test discipline, not a P0101 specific pinpoint tree, setting formula, circuit callout, confirmed repair, or verification routine. So do not turn this code into a parts call. Prove the concern first, then work the checks in order. Begin by confirming the concern is actually present. If the concern is not present, do not replace modules or other components just because a test might seem to point that way. Start with the obvious checks that match the customer's symptom. Look for service information that may apply. Check whether a previous repair was done incorrectly, and make sure the battery and charging system are healthy. Before getting into diagnostics, battery SOC needs to be greater than 70%. Then scan the vehicle broadly. If other codes are present, use them to decide where to start. Circuit-related codes get handled before system or performance-type codes. If several circuit faults point in the same direction, look for a shared power or ground issue instead of chasing each one separately. Once the basic direction is set, inspect the vehicle like a technician, not like a parts catalog. Check harnesses for damage, chafing, and routing. Check fuses, circuits, connectors, and component connections. For P0101, pay close attention to the air side. Vacuum lines, the air intake system, and hoses need to be checked for leaks, blockage, restrictions, and correct routing. Then keep going through the supporting engine checks. Fuel quality, fuel tank and fuel lines, coolant level and quality with the engine at correct temperature, oil level and quality, and the exhaust system for damage, restrictions, and routing issues. These checks can explain an airflow performance complaint before any electrical teardown is needed. When you do get into connectors, protect the terminals. Use Rotunda Flex Probes NUD 105R025F or Terminal Probe Kit 418S035 when connecting test equipment or jumper wires to pins. Check male to female terminal fit with the mating pin and feel for normal separation force. A damaged terminal can have very low separation force. If the connector shell, guide, or retainer adds drag and prevents a proper check on small pins, remove the pin as needed so the terminal fit can be evaluated correctly. Damaged connectors, pins, or terminals are the parts this diagnostic supports replacing. Use the scan tool to read PID input values, output states, and diagnostic states. Monitor the data in data logger so you can catch what the module is seeing without unnecessary disassembly. Before blaming a module, understand normal system operation. Make sure programmable parameters are set correctly. Resolve codes in the proper diagnostic order. Test hardwired and networked inputs. Test outputs, and check for module software updates. If you are checking module switching circuits, use output state control to command components. If the module output works normally, shift your attention back to the inputs instead of condemning the module. Unnecessary module replacement usually comes from incomplete testing, and jumper wires should not be used to feed power or ground directly into module switched components unless the test specifically calls for it. For a power-providing circuit carrying approximately 200-1000 mA, load the circuit with a 250-350 m, a test light, and measure voltage with the DMM while the light is connected. If voltage drops under that load, excessive resistance is indicated. Conductor size helps you choose the right kind of load. Conductor sizes 24 gauge, 0.5 mm, or smaller are generally used to carry approximately 1000 mA 1 ampere or less, while conductor sizes 20 gauge 0.8 mm or larger are generally used to carry 1 ampere 1000 mA or more. For circuits carrying more than 1 ampere, load the circuit with a device that requires similar current. For higher current circuits, use voltage drop. Ground circuits should be checked by measuring voltage drop while the component is operating or being commanded on. Use an ohmmeter on ground circuits only if the battery has been disconnected. On most small diameter, 18 gauge and smaller wires, expect less than 2 ohms, and for most wiring harness circuits, expect less than 2 ohms. Keep in mind that a standard DMM ohmmeter's low resistance resolution, approximately 0.1 ohm, limits its accurate use to circuits carrying less than approximately 5 amperes. Reverse the DMM leads and see if the reading changes. If it does, and there is no semiconductor in the circuit, treat the result as invalid. To check unwanted continuity to ground or to another unpowered circuit, disconnect both ends and expect resistance greater than 10,000 ohms. To check unwanted continuity to a powered circuit, disconnect both ends, turn ignition or run power on, and look for no voltage on the suspect circuit. Backprobing is only for situations where the circuit must be tested under actual operating conditions. Do not force probes into connectors. Use the right back probes, and do not use backprobing for a single-point voltage check or for continuity and open circuit checks between 2 points. Bad probe contact can look just like a real 0-volt or open circuit result. With jumper wires, always use fuse jumpers. The recommended universal testing jumper wire fuse is 5 amperes or less. Flex probes help prevent terminal damage, but they are not meant to carry high current greater than 5 amperes. For voltage drop testing, connect the voltmeter at the beginning and end of the suspect circuit, operate or attempt to operate the circuit, and keep meter polarity aligned with conventional current flow. A normal 12-volt circuit usually shows less than 0.5 volts, or less than 5% of circuit operating voltage. Greater than 0.5 volts indicates abnormal voltage loss from high resistance in wiring or connectors. If a voltage drop test reads 0, first, suspect bad meter connections or that the component was not actually turned on. In a voltage in voltage out check, the power side should be within 0.5 volts of battery voltage, and the ground side should be greater than 0 volts but less than 0.5 volts. A reading of 0 volts or source voltage points to an open circuit. And do not repair a circuit by adding a parallel wire until you understand why the original circuit failed and have checked the nearby wiring damage. For this P0101 episode, the takeaway is simple. Treat the code as an airflow performance concern, but do not guess at a mass airflow sensor or a module. Confirm the symptom, handle circuit faults first, inspect the intake and related engine basics, protect the terminals, and prove the circuit with the right test method. Because the P0101 specific pinpoint and final verification routine are not included here, pause before any repair decision, recheck the earlier diagnostic path, and avoid guessing. For more diagnostic training, visit stepdiagnostics.com.